All right, here we go. Looks like it's going to work now. All right, so anyway, yesterday, right, we worked on some coordinates plane stuff with circles, and we're going to finish it up today. All right. So we're not going to worry. I mean, it's calling writing a coordinate proof, but we're not going to so much worry about I don't know. It's not proof in the sense of how we've done things before with statements and reasons and stuff. We're just going to kind of show our work to guarantee things. So we'll go through an example here together the book has done for us, and then we'll try one on our own here in the back with using their dumb blanks that they have. And then there's an additional one or two there in the book that we'll try as well. Okay, and then we'll go on, like I said, to a few other kinds of problems that I want us to be able to answer too. Okay, so let's go here. Our directions here for example 3 are to prove, and again we're on page 893. In example 3 we're asked to prove or disprove that the given point lies on the given circle. So this point 3, comma the square root of 7, okay, show that that is on the circle centered at the origin and contain the point -4, 0. Okay, so our circle here is centered at the origin and it contains the point -4, 0. All right, and we want to use this information to then determine if this point is on our circle. So the first thing it suggests that we do here, for step 1, it says plot a point at the origin for the center of the circle and at -4, 0, and then use these to help you draw the circle centered at the origin that contains the point -4, 0. And so then they do that right there. Okay. What's the radius for the circle going to be? What's the radius for the circle? It's 4, right? Yeah, if we count from the center here to any point, 1, 2, 3, 4, it's 4 units away. Okay, and in fact, that's what we're told right there, too. Okay, radius is 4. Okay, well, if we know the radius and we know the center of the circle, we can write the equation of the circle, right? And so we use the circle formula here, equation for the circle. Okay, h and k are both 0 because it's centered at the origin, and the 4 is our radius. And so we get x squared plus y squared equals 16. That's the equation for our circle. Okay. Now, we have the equation for our circle, but we want to still figure out if this point is on our circle. So how can we use the equation for our circle to determine whether this point is on the circle? What should we do? What should be true about this point and the equation for our circle here? What should be true? Well, if I gave you the equation for a line, and I asked, is a particular point on this line? So let's say I gave you the equation, I don't know, like y equals, 2x plus 7. Okay, that's a linear equation, right? It's in slope-intercept form. Let me ask the question, is, 3, 1 on the line y equals 2x plus 7? How can we determine if 3, 1 is a point on the line y equals 2x plus 7? What can we do? What's that? Plug in the 3 and the 1. 3 should go in for the x, and 1 should go in for the y. Okay, so 1 equals 2 times 3 plus 7. Is 3, 1 on our line? Well, 2 times 3 is 6, plus 7 is 13. Does 1 equal 13? No. So is 3, 1 on this line? No. It doesn't make the equation true, so it's not a point that's on the line. Well, 3 square roots of 7, if that's a point on the circle, it should work in the equation for the circle. So substitute the x and y coordinates of the point 3 square roots of 7 into the equation of the circle to check whether they satisfy the equation of the circle. 3 squared in for the x, so 3 in for the x, root 7 in for the y. 3 squared is 9, square root of 7 squared is 7, 9 plus 7 is 16. So is this point on the circle? Yeah, it is. So the point 3 square root of 7, 3 comma square root of 7 lies on the circle because the points x and y coordinates satisfy the equation of the circle. Okay, that's all there is to it. Questions on any of that? All right. Let's try this one here then. All right, so, excuse me. We're asked to determine whether this point is on the circle with center at -1, 0 and containing the point -1, 3. Okay, so we're going to plot our circle's center at -1, 0. So -1, 0 is right here. Okay, there's our center. And it contains the point -1, 3. So -1, 1, 2, 3. Okay, so then what is the radius of our circle going to be? If that's our center and that's a point on our circle, what's our radius going to be here? 3, yeah, r is 3. And so from our center, we can also then go 3 to the right if we want to, 3 to the left, 3 up we already have, and 3 down, and then circle around those points. Okay, something like that. Okay, so there's my lopsided circle. All right. And then we use the radius and the coordinates of the center to write the equation of the circle. So what is our h going to be in this case? Again, remember the center is -1, 0. So what is our h? -1. And what's our k? 0 from that point there, yeah. And then what's r? 3, right? We just figured that out too. So x minus -1 becomes x plus 1. Y minus 0 is just y squared. 3 squared is 9. So we have the equation x plus 1 quantity squared plus y squared equals 9. Oops, I'm off the screen there. There we go. Okay. And so now to check to see if the point 1 comma square root of 6 is on our circle, what's going to go in for x? 1. So it'll be 1 plus 1. And what goes in for the y? Square root of 6. Okay. And that's got to equal 9. 1 plus 1 is 2. Squared is 4. Square root of 6 squared is 6. 4 plus 6 does not equal 9. So the point 1 square root of 6 is not on the circle because the x and y coordinates of the point do not, let's see, I'm not sure what words to use there. Do not satisfy. The equation of the circle. Okay. Okay, do not satisfy the equation of the circle. All right. Questions on any of that? So you can check to see if points are on our circle by plugging them back into the equation. That is true for any kind of graph that you have. Anytime you have, you want to determine if a point is on a particular graph, you can plug that point into the equation for the graph and see if it makes the equation true. All right. That's how we arrive at a graph of something, is we only plot points that make the equation true. All right. So I'm going to give you guys one here. Why don't you guys go ahead and try number 12, okay, at the top of the next page there. Okay. So number 12 says point square root of 18 comma -4. That's the point you're supposed to check to see if it lies on the given circle. So the circle is centered at the origin and contains the point 6, 0. Okay, so go ahead, try that one right there. Just try number 12. Okay. Oops. the equation for your circle, and now just check the point in the equation. Okay, so let's simplify here. Like 1 more minute here. All right, Preston, you got an answer for us, sir? Yeah. Okay, so does the point work or not?
I said it doesn't work.
It does not work. Okay, sounds good. Yeah, we end up getting 34 instead of the r squared of 36 that we need there. And so the point does not work. Okay, questions on any of that? So we're going to go off book a little bit here, all right, and adventure a little bit into some pre-calculus material. So, I mean, if you were taking my pre-calculus class, these are questions that we would kind of cover very, 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 very early on in the class, but it is that kind of stuff, okay? So, unfortunately, it's not in the book, so you can follow along on a separate sheet of paper, you know, or just follow along as best you can here. You will have a few of these problems for homework here. Okay, but I figured that, you guys, you should be okay for some pre-calculus, okay? All right. Again, it's not too terrible because it follows right from the kinds of questions that we've already been doing. And we won't do a ton here. I think we'll do maybe like just 2, okay, and get you the idea from there. All right, so more coordinate plane circles. Okay, I don't know if that's a better way to good note title, but it's really just more circles with the coordinate plane and stuff like that. Okay, we'll just like two problems here. We'll kind of talk these through together. All right. Start with this one. A circle has C center at 3, -1, and a point on the circle at 2, -2. Okay, oops, I'm off this. There we go. A circle has center 3, -1, and a point on the circle at 2, -2. Write the equation of this circle. Okay. Now remember, to write the equation of a circle, x minus h quantity squared plus y minus k quantity squared equals r squared. We need h, k, and r. Okay, to write the equation of a circle, right? That's what our goal is here. Write the equation of a circle. So we need an h, we need a k, we need an r. Do we have any of those pieces of information given to us already here in this problem? Okay, we know what h and k are. What are h and k, Jackson? So h will be 3, k will still be -1, but then we plug them in, yeah, they'll be the opposite. So it'll be x minus 3. Yes, exactly right. So x minus 3, quantity squared, plus y minus -1, okay, equals then our radius squared, which I'll go ahead and just simplify that to be x minus 3 squared plus y plus 1 squared equals r squared. Okay. We're not told our radius, are we? Right? All we've got is another point, bless you, on the circle here. How could we find our radius, though? What could we do? What's an option here? Jenny? Find the distance between what? Isn't that the definition of what a radius is? Distance formula, or the distance between the center and a point on the circle? Absolutely. So option 1, use the distance formula. So distance equals the square root of, and we'll subtract our x coordinates, so 3 minus 2, plus, subtract our y coordinates, -1 minus -2, squared, of course. Okay, so x minus x squared plus y minus y squared. And so let's see here, 3 minus 2 is 1, squared will just be 1. -1 minus -2 is really plus +2, so -1 plus 2, 1, squared is another 1, and so we get the square root of 2. Okay. So the radius then is the square root of 2, which means then the equation for our circle will be x minus 3 squared plus y plus 1 squared equals the square root of 2 squared, which is just what? 2. So there's the equation of our circle. Did anyone have a different thought about how we could find the radius in this case? Anyone have a different idea? Okay. Jenny, you have another idea? Okay, so yes, I think. Say what now?
I said I don't know if that works every time.
So yes, so if this circle equation, okay, we know this circle exists. In this case, we know that this point is on the circle, right? In the previous problems that we did, we were told, come up with the equation for the circle and then determine whether this point is on the circle. But we're told now this point is on the circle, which means it must work in our equation here. So an alternative, use the point 2, -2. Just put it in the circle equation. So 2 is our x coordinate, so it'll be 2 minus 3 squared plus y, which is -2, minus, or plus 1, I guess, squared, whoops, equals radius squared. 2 minus 3, -1, squared, positive 1. -2 plus 1, -1, squared, positive 1. R squared is 2. Okay? And in fact, we can stop here. It's not necessary to solve for r, because what do we need in our equation? Do we need r in our equation? What do we need? We need r squared. We already have r squared. Right there it's 2. So we don't need to continue by square rooting. It's not necessary. I mean, you could if you wanted to and say, aha, the radius is going to be the square root of 2. But we only need r squared, so we need to substitute in for r squared there. Boom, there it is. It's 2. So 2 options. You can either use the distance formula between the center and the point on the circle, or use the point in the equation to help you solve for the radius. Your choice there. Okay? Questions on any of that? Oh, yeah, Avery?
Does it help how much
Essentially, yes, right? Because how did we determine the equation for the circle yesterday? Well, we used Pythagorean theorem, but we know Pythagorean theorem is really a distance formula. And so, yep, a circle equation is really a distance formula. Yep, it's pretty much the same thing. Yep. All right, that was one scenario there. Let me throw one other scenario at you here, and then we'll stop for you guys get started on your assignment. All right, scenario dos. A circle has endpoints of its diameter at 6, 0 and 0, 10. Write the equation of the circle. Okay, so again, our goal is x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, so this is a little bit different. Okay, we want to write the equation of a circle. We need a center, we need a radius. Are we given the center of our circle in this problem? Are we given the center of our circle? No. Are we given the radius of our circle? No. All we know are the endpoints of a diameter. I know I said its diameter, but really there's an infinite number of diameters there. So the endpoints of a diameter of the circle, the endpoints are at 6, 0, and 0, 10. Okay, Jenny? What would the midpoint of the diameter find for us? Okay, we can use it to find the radius. What else is going to be located at the midpoint of the diameter? The center of the circle. Yeah, the center of the circle. So let's do that, okay? So first we'll find the midpoint of the diameter. Okay, so it's going to be 6 plus 0 over 2 and 0 plus 10 over 2, which gives us 3, 5. So that is our center there. I'll put the C there for it, for center. Okay, and now that we have the center, and we have 2 points on the circle, how can we go about finding the radius? Distance formula, or plug it in. Yep, it's just like this problem now. Right? Once you found that center, you can now use either of these two options here to find the radius. Okay, so I'll go ahead and I'll just use, so I'll say use option 1 or option 2 from above, right? To find R. I'll use option 2 here. So I'll say x minus 3 squared plus y minus 5 squared equals r squared. I'm going to plug in one of my points. Does it matter which point I plug into my circle equation here? Nope, they're both on the circle, so I'll plug in the first one. 6 minus 3 squared plus 0 minus 5 squared equals r squared. 6 minus 3 is 3, squared is 9. 0 minus 5 is negative 5, squared is 25. 9 plus 25, 34. R squared is 34, and so we have the equation x minus 3 squared plus y minus 5 squared equals the square root of 30. Whoops! Equals 34. Okay. There's the equation for our circle. That's it. Alrighty. So that's what I do on day 2 of pre-calculus. Right there. So if you're happy for pre-calculus, you might see this again. Okay? Questions on any of that? All All good? Okay. So, let me give you your assignment then, okay? So, and forgive me, it's going to be some in the book and some from the Google Classroom. Okay. Okay, page. So the book will be starting on page 896 again. But now I'd like you to try numbers 10, 12, 18, and 25A. And then also, I'll load up on the Google Classroom here an assignment as well. It's going to be a worksheet. I think it's called like Equations of Circles Worksheet, I think. Okay, and that one I want you to do page 1, just do numbers 1 and 2, and then page 2. I got to figure that out still. So I'll put those up here in just a sec. But there's something at least to get started.